Hi and welcome to my Python YouTube channel. It's awesome to have you here. If you like this video, a thumbs up would be great. And make sure to subscribe for future videos. I also have a blog at prosperocoder.com with lots of cool stuff, so feel free to check it out. Today we'll be talking about missing data in Pandas. In real-life scenarios, data is seldom complete. How does Pandas handle missing data? Generally, it uses two null values, none and nan, the letter standing for not a number. The problem with none, though, is that it's a Python type. To be precise, its D-type is object. If you use it in a numpy array along with integers, where all elements must be of the same type, the nearest common type for integer and none will be object. Have a look at this. We have our imports, and now here we created a numpy array with the following elements: 1, 2, 3, none, 4, and 5. This is the Python type none. Let's print it out. So as you can see, we have an array, and the D type is object, the smallest common type. Now, it takes much more time to process objects than integers. So what about the other null value, nan? Well, the D-type of nan is float 64, and it's defined in numpy. So let's recreate our numpy array like so. Now we use nan defined in numpy, and let's print it out along with the D-type. So, as you can see, now we have an array with this element over here, and now the D-type is float 64. Now, if used in operations, the best common type for nan and any other type is nan. So, for example, if we add a nan value to any integer, we still get a nan value. If we multiply any integer by nan, we get nan. What about aggregates? Let's see. We're going to use the nonce array with the nan value defined a moment ago. How about the minimum value? Well, the minimum value is nan. How about the maximum value? The maximum value is, again, nan. What about the sum? The sum is, yeah, sure, nan. Well, so it works. We don't get an error, but we don't get anything useful at all, to be exact. Fortunately, there are methods in numpy that ignore nan values and take only the values that are not nan into account. So, if we need the minimum value, we should use nan-min. Let's try it out. Good, this time we get 1, so the nan values are ignored. If we need the maximum value, we can use nan-max. Now the result is 5. And if we need the sum, we should use nan-sum. Now the result is 15. Good. Now in practice, none and nan are used in a similar way. There are a couple operations that we can perform on data with null value. The first thing we can do is test for null values. The two methods we can use to do this are isNull and notNull, with pretty self-explanatory names. They both return a mask over the data. Let's check them out. First, let's create a series object from the nonce array. And now, let's use the isNull method. So, we get this. This is a mask. Now, this element is true, element at index 3, because element at index 3 is null. Here you can see it. Element at index 3, 0, 1, 2, 3 is null. Yeah. And now, let's check not null. So, now we get false for the element at index 3, because not null is true for the other elements and not for this one. For this one, not null is false. Yeah, and now we can use these masks to index the data. So let's index the data with the isNull method first. Here we have our series object, and we're indexing it with this function here. So the result is only one element at index 3, nan, because we used this mask, which returned only this element over here. How about the notNull method? Well, we can use it to index the data too. And now we have all the elements for which this returns true. So all the elements except this one here. Good. Now, you can easily remove null values from a series object using the dropNA method. So here we have our series object, and here we have our dropNA method. So let's use it. Now, as you can see, the null element at index 3 was removed. Fine. Now, with the data frame, the problem is that by default, a whole row or column is removed if at least one value in that row or column is a null value. Let's create a simple data frame object to demonstrate it. Here it is. Let's print it out. Yeah. As you can see, here we have null values. And now, if we use the dropNA method, we'll get this. So as you can see, the first and last rows have been removed. This is because the method removes all rows with null values by default. If you want to remove columns with null values instead, you just have to specify the axis. So axis 1 is for columns. Now we removed these two columns because they contain none values. And we can also use this explicit naming convention. So instead of passing 1 as the keyword argument to specify the axis, we can use the name columns. And the result will be the same. Fine. So the first column is here, and the second one and the third one have been removed because they contain none values. Now, if there are lots of rows and columns and quite a few null values, it may happen that most or even all of them will be removed. This way we'll lose most valuable data as well. This is why we can use the parameter how, which is by default set to any, and set it to all if we want only those rows or columns to be removed where all values are null. Now let's modify our data frame a bit so that the second column contains only null values. Good. As you can see, we have only none values here. And now we remove only the columns where all values are null. So we have to use the axis argument set to columns and the how argument set to all. And now we get this. So only the second column is removed because only this column contains all elements with this value. Fine. And there's also the thresh parameter, which you can use to set a minimum number of null values in a row or column. Only rows and columns with minimum that number of null values will be removed. So here's how we can remove rows with minimum 2 null values, which in our case means just the first row. Here we have the thresh parameter set to 2, and now we get this. So here the first row was removed because it contained 2 none values, but the other rows have not. Good. Now one more thing, we can fill null values. Sometimes you may want to replace null values with some default value like 0 or by an interpolated or repeated value. This is where the fillNA and interpolate methods come in handy. Let's have a look at our series and data frame objects again, because we don't remember what they looked like. It was quite a long time ago when we created them. So here is our series object again, and here is our data frame object again. And now let's have a look at the fillNA method, how it works. So let's fill all null values in the data frame with zeros. To do that, we use the argument 0. And now the result is here. So all none values have been replaced by 0. Now Let's propagate the previous values forward in the series. So we have to use the fill and a method with the method argument set to ffill, forward fill. And we get this. So as you can see, here we had nan at index 3. Now we have 3 at index 3 because we had 3 at index 2, and this is forward propagation. So this value has been propagated to this place. Fine. And now let's propagate the next values backward in the data frame. This time we need the bfill method. So here we get this. As you can see, we had a nan value here, and now we have 9, because here we have backward propagation from here to here. Now, as you can see in the last example, the values are propagated only if the next value isn't a nan itself. This is also true about forward fill that we saw before. And now, have a look at this example. Fill and a, the method is forward fill, and the axis is columns. Now, we have this result. So as you can see now, here we had the nan values and here, and now the values are replaced by the ones which are before them. So 4 from here is propagated to here and to here. Now 7 is propagated to here and 9 is propagated to here. Good. And now let's use the interpolated values in the series object. So I have to use the interpolate method. Now here's our series object. Here we had a nan value. Now we have 3.5 because here the value is interpolated between 3 and 4. And finally, let's use the interpolated values in the data frame object with a specified axis. So 1 stands for columns. And here is the result. The values are interpolated. So 4, 4, 4. 7, 9, and here we have 8. 9, 7, so here is the interpolated value, 8. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.